I know some people have to go at 4 o'clock or
Yeah.
maybe even
Yeah,
earlier.
earlier.
So.
Do 3:30.
Yeah.
Okay. Okay.
So that's fine. It's a bit unfortunate today. Well, thanks you all for coming because the math celebration got scheduled at the same time and I didn't really realize until it was a bit too late to do anything about it. So thanks for coming anyways. And so there might be some other people coming in, but I'll just get started. So this is a little pet project of mine that took quite a lot of my summer, last summer really. To not say the entire summer, but I spent a lot of time on this. The idea is, well, I have been teaching a few courses now in the department, and before that I was a college teacher as well in Montreal before I moved here from grad school. And so I've had a fair amount of experience with sort of more traditional lecture style delivery. And so today what I'm going to present is basically the result of a change in behavior or change in habit in what I was doing in my classes over the last summer. Okay, so here's my test case, basically. So this is the class I've been teaching the most here at UVic. So Math 200. So Math 200, I mean, I imagine most of you are familiar with it, taught it, or took it, or at some version or another. So yeah, and so basically this class here is a difficult second-year class for students. The prerequisites, Calculus 2, so they need to do Calculus 1, Calculus 2 in first year, and then they move on to Calc 3, which is this class, in second year. Has 3 hours typical of contact hours and 1 hour tutorial per week. And the typical audience you have is engineers, physicists, mathematicians, other science, so I have some chemistry and some other students as well, or economics as well. Okay, mostly engineers, I guess. And the content, well, is Calc 3, so we've got all what we do in Calc 1 and Calc 2, but in 3D. So we have vectors, partial derivatives, multiple integrals, and a bit of vector calculus at the end. Okay, so this is roughly what's going on in this class. Now, I have taught this class twice, in the summer of 2011 and the summer of 2012. Okay? And I'm sharing you here, these are the results of my course evaluations for both of these. Okay, and so I was teaching this class in a very traditional lecture fashion. I would give time in class for exercises and a go around, but it's a very large class usually, so it makes it a bit difficult to do that. And it's a difficult class in the sense that there's a lot of material in that class. There's a lot of stuff to cover. Okay, and so this is what I've done summer 2011, summer 2012, and these are the results I was getting. So the first time you teach a class, I mean, of course, you just try to survive more than anything, but then the second class, second time over, you can try to do a bit of improvement. And so I was fairly satisfied with those numbers, but this one in particular here's course provided opportunities to engage with the course material. So this one here was a little bit lower than all my other numbers, and I was not necessarily particularly happy about that. So that was summer 2012. The course of that year, I was thinking a bit about how I could actually make things different. And I eventually ended up in a teaching workshop that Alfonso was running at the time, for those of you who know him. And then I've had heard as well of some different techniques used, for example, by Jason in Math 100, I think it was. And then Rod as well, using things like this in the math department. And so this sort of spanned my interest, and I took this workshop. And then I got introduced to this idea of the flipped classroom. And I decided it was a pretty good idea, and I was going to try to do that. Okay, so yeah, so having this here, I mean, this weren't bad, but like I said, this was the main thing I wanted to change, to try to get the students to engage more with the material, okay, as a general topic or goal. So in the summer 2013, then, I sat down before I taught this class again, and I got some objectives, things I wanted to change that summer, with respect to the previous time that I was teaching it. Okay. So my macro objective, so the big picture objective, was to basically increase student engagement inside and outside the classroom. Okay, so I wanted people to connect more with the material, have more time to engage with respect to it. And so that was my global objective. Now I had some smaller micro objectives, which were the following. So I wanted to decrease the student note copying in class, which I found very often I was doing. You know, I go on the board and then I write a definition, I write a proposition, a result, or something like that. And we spend a lot of time just copying down what I'm writing, and the students are just copying what I'm writing too. And so it's just, I thought, after especially I've been exposed to different methods, it was a very inefficient way of using class time. So this was one of my micro objectives. Increase teamwork. Okay, so this is also something I wanted them to talk to each other more and to participate more in the class. Increase the number of problems solved by students. So to do more problems, really, because this, you have to keep in mind, I was teaching this in the summer too. So temperature was really not on my side most of those summers. So it's a difficult class to teach. I was teaching it Monday, Thursday, 8:30 in the summer. So it's very difficult for them to do anything outside the classroom, for attendance as well. So I was fighting against a lot of things here. And so this was also here, with respect to this and to these factors. And then as well, increase students' pre-exposure to material. So I wanted them to have an idea or think a little bit more about what was going to happen in class before they showed up to class, okay? Which is actually one of the components I found was the most difficult to achieve. And this is the one that the flipped classroom actually addresses really well. Requires a lot of disciplines on the students' part, and I'll get to that. But, yeah. So I had this in mind, and now I went on and tried to plan my course for the summer, Math 200, with these things in mind. So, yeah. So what I did is the following. So I had this idea, basically, that I wanted to do the flipped classroom, which involves basically me making videos of the material or presenting the material in some form or another that the students have to watch before coming to class. And when they are in class, then we focus a lot on problem solving. And I did it in a way very similar to what's called the Eric Mazur style, I guess. So I don't know how some of you are familiar with this. I'll get to that eventually. But I knew how much work it was going to be. And then also, well, I apprehended that I actually did. I can't say I really knew, because once I was doing it, I realized how much work it was. So I didn't really know, but I apprehended. And so I thought to myself, well, realistically speaking, maybe I could just convert about half my class, or half my contact hours, to flipped classroom and just remain somewhat more traditional for the other 50%. And actually, originally I had a sort of a 60-40 plan in my head, and eventually turned into more 70-30. That's actually what happened here, more or less. Okay. So first of all, and second of all, I was also afraid it's a summer class that the students would not watch the videos, because if that happens, then you're doomed. Okay, if the students think it's too much work, or eventually there's something that happens and they just stop watching before they come to class, then what you do in class is not very worth much, because you're just starting to do a bunch of problems that they don't know the theory, or they haven't really thought about it before coming to class. And so having both of these things in mind, I decided not to do a full 100% flipped classroom. I decided to basically split it, having all these objectives in mind. And then, so this is basically what happened. Okay, so first of all, I'll describe a little bit the flipped classroom component. Okay, so what I've done for those sessions. So basically, I had a certain twice a week I was meeting them, so I had a certain number of sessions in the end. 70% of them, or roughly, they had to watch videos before, and once we were in class, we were doing problems. Okay, flipped classroom. And the other 30% or so, I'll get to it, was a bit more traditional. Okay. So, let me explain first what happened in this case. So the flipped classroom. I imagine most of you are familiar with this now. Really, the idea is that, well, in the format I'm using, students have to watch a series of videos available to them in two different places, so I'll get to that. That's something that I've actually done, and it looks crazy, and when I was doing it, people were like, you're crazy, but it's not that crazy, and you'll see why, okay? And this is one of the, I think, one of the big aspects why it made it so well received in this, with the students, okay? But before you open your eyes too much, let me convince you that it's not actually too bad. So in the classroom, students solve problems using clickers. Okay, so it's a big class, so we have clickers, and then I'll get to the details of this here, but this is roughly what happens. Okay. So let me start with the videos. So prior to class, students have to watch a certain number of little videos that I created. Okay? And one thing that actually made it hard for Math 200 is that now you're starting to get a bit of a higher level. If you teach Math 100 or some first-year classes, then there are a lot more resources available on the web. Now, if you start going to high level courses, for example, Multivariable Calculus, not that many good videos available. Actually, not many at all that I found. So eventually, after just spending hours and hours of just searching and watching videos, I just decided that it was easier to just do them all. So I did it, okay? And before coming to class, well, the students had access to the website, okay? So here's the course website, it's just a portion of it, that said, prior to every day, what the students had to watch before coming to class, and they knew it, okay? So I was telling them, if you don't vision or watch those videos before you come to class, you will not be able to follow, because they were very much warned at the beginning. So those slower pace and faster pace were exactly the same video, but just at a different pace. Okay, and I'll explain to you why or how I did that. Okay, and how it's actually not too bad, not too much work to do it. And sometimes they had optional videos they could watch if they wanted additional examples. Okay, so all there, and then they would just, for example, for the Monday, June 24th, and then they would know they would have to watch either those three or those three here. Sometimes when I have a very short video, I would make two here, and then sometimes an additional example. And so they have to watch that before coming to class, and then on Thursday, June 27th, they didn't have to watch anything because then we were doing more traditional approach. Okay. And so this is what they had. Now I also created a YouTube channel to make it easier for them to find all the videos. So they have this list there, very clear what they have to do. But also there, they had a big playlist on this channel where they could just click play on the playlist and the videos will keep going one after the other. And if they felt like watching a bit more, then they could, you know. And so it was totally up to them how often they wanted to do this and to which pace. So now I put it all online here on YouTube. And then I give it a little design here. There's a bit of a running gag with a cat there. That's actually my cat. And what happens is I was doing a lot of those videos at home, and when I was talking to the screen, my very needy cat came and often meowed in the background. And so instead of, well, at first what I was trying to do is I was trying to chase the cat with a broom or something while I was keeping to talk, give my lesson. And eventually I decided to just give up because I had to redo my videos all the time. And so in a lot of my videos, you hear just meowing in the background once in a while, and the students thought it was really funny. And instead of just trying to get rid of the cat, I just integrated it as the mascot of the So that actually turned out pretty well. Yeah, so that's everything here. So now let me show you an example of two videos. Okay. So I'll start with the one slower paced video, and I'll show after that the faster paced video. Okay. And they're both meant to achieve two different things. So let me see here if I can start this.
Limit.
Okay, so let me just. Okay, so I'll just make you watch maybe a minute or two so you'll get it. I won't make you watch all 15 or 20 minutes of it. Okay, let's see. Okay, I'm sorry, I think I will have to log on again. UVic open is very nice for that, just keeps you up whenever you need it. Okay, good, super. Just a minute. Alright, let's go back to business. Okay, so while this is loading, okay, well, good, yeah. Just find it back. Okay, hopefully it's going to work.
The function actually a limit.
Okay.
Or a limit of a function of more than one variable. So before we jump in the case of functions of two variables, let's go back to the case of function of one variable. Let's take, for example, the function f of x equals x squared. So the parabola. And in this case, well, the domain of my function is part of the real line. Alright? So let's plot it first. So just do the regular xy plane. And the parabola. Like this. And like this, roughly. Alright. Okay, so this should be symmetric here, but you know what I'm drawing. So let's take, for example, the point 2 here, x equals 2. Okay, its corresponding point on the graph here is 4. So if I just put the corresponding dashed line here.
Okay, so I'll just fast forward a little bit further. So you see here, what I'm doing is basically just like in a lecture. Okay, so I'm just there on my screen and I am
here. What I would get is 0 over 0. So in this case here, we actually have...
So for this video, first what I did is I presented, I'm introducing the notion of a multivariable limit. So I'm recalling first what is the notion, the equivalent notion for a function of one variable, and then eventually I move on to multiple variables. And then I do some examples.
0. The division equals... This is what we got.
Here,
okay, and it also seems that no matter how we go to the point 2 here, this z value would always get closer to 1/2. Okay, so the surface here is very nice, and so when I approach 2,
so I won't make you watch the whole thing, but basically this is the idea. So I do a screen capture on my screen. I just go around and I explain just as I would do in a lecture, and then I bring in some graphics sometimes to explain what's going on, like this. So those videos are quite long, okay, as you can expect. And so this is originally what I started doing when I started doing videos like this, okay? And so I had in mind, okay, well, the students are going to take notes at the same time, and then they'll watch this before class, and after that, we'll do some problems in class. But now after having showed this to a few people and then trying to get some feedback before I actually run it to the students, they were like, well, this is really long. Okay. Some students won't be willing to go and face that 3 times that sometimes before every lecture or every other lecture. And so I went back home after that, after I've been talked to a lot of people, or a few people who had experience with this before, and I wondered what I could do to actually make this shorter, because I still wanted to get the explanation through. So then I decided to make, so if I just go back, this here. So this is exactly the same video, but now the difference.
Hi again. So this video is going to be introducing the concept of a multivariable limit. So first of all, let's go back to the case of a function of one variable, and let's just remember how a limit could be defined. Okay. So let's take the function f of x equals x squared. And here we are taking the domain of this function just to be in the real line. So this is a function of one variable. And the graph of this function is just a regular parabola. Okay? And if we consider, for example, the parabola, the x value 2 here, then the y value associated on the parabola is 4. Now, when I'm actually approaching the value 2 on the x-axis, there are 2 possible ways I could approach the value 2 here. I could approach it from the right or approach it from the left. Okay, and we write in both of these cases that the limit as x goes to 2 minus.
Okay, so this was just to give you a little idea here. The idea is I kept exactly the same text. Okay, so everything that I wrote, the first attempt or the first time I would do a video, I would do this slower pace video, and where I would just write at the same time and create a fairly long video. But then after that, what I would do is I would just save everything I've done on the screen and just reread over it to get something that was much faster. And so then the extra work to actually do this versus having only the first take. When you have the first take video, you have to plan what you're going to do, you have to plan all your graphics, you have to make them, and then you have to somewhat have a nice script that goes with that. The second time, I just redid it while reading it. So really, the extra work of doing this second pace was not actually that great. Really, the amount of time I spent was mostly on this first take, the slower pace, and then I would just read the faster pace. And eventually, I got better at it, and I would do the slower pace in 2 takes, maybe, and then I realized that there's no way I could be perfect on all of those videos. I make mistakes sometimes, and then I correct them in class, and then YouTube has this nice features that you can actually go and then create a little bubble here, speech saying, actually, this is wrong here, this should say this, or this should be that. Because you spend so much time just redoing it and redoing it and redoing it, you're not going to be perfect. And so I have to just stop myself from trying to be perfect, and then I just started making videos. And after that, I made some edits on them. Some of them I redid later on, but most of them I kept. And then the faster paced ones, I just created very easily after. Okay, so then students had access to both of these spaces, and then they could watch either or both if they preferred. Yes.
I was getting to the issue of what did your students do? Did you ask them?
So I will get to that.
Okay.
So I ran surveys to see what was happening. Because I was doing this, I was thinking, okay, well, they'll have both, so they will eventually watch either one of them. And so we'll see. Okay, but I just wanted to point out that this was not actually much more work than doing the first thing. And really, you have to keep in mind, I was not doing that for 100% of the classes. Okay, initially, and this will be one of my big take-home message at the end, it doesn't need to be 100% right away if you want to do this. You can integrate this slowly into the class, because it takes a lot of time still to make those videos and make them good. Yeah.
I think too for, I mean, obviously with math, a lot of it is board work.
Yeah.
You know, primarily in the past. For a lot of faculty, they probably have a lot of PowerPoint slides already.
Yeah.
And it might just be a voiceover.
Yeah.
As if they were teaching in class with the PowerPoint being the main focus of the whole session.
Exactly, exactly. So that, I mean, that applies specifically more to math, what I'm showing you, but this is a good point, yeah.
And also too, I know that I've seen it in a few other cases where people in the YouTube video have often in the comment field below put different time sequences. So like at 4 minutes into the video, that's when we're talking about this particular item. Or this particular item. And I know a lot of students will often go back before a midterm or whatever to go back to those points, or maybe after a lecture, go back to review that certain point.
Right.
And the fact that you can actually stop it and review it, that often helps get those difficult
Right, and this
theories.
is probably a good thing to do when you have long videos.
Mhm.
When you have very short videos, then you can just tailor
Just
it.
by topic, yeah.
Yeah, exactly. But this is a good point. So you can edit them afterwards. You don't have to just think you have to be really perfect and do one. That took me a while to get over that. But yeah, so this is a good point. And so just before we keep moving, some statistics. So I made a total of 44 mandatory videos in the summer. Okay, so they had to watch 44 videos throughout the whole summer. Now, 18 of them were optional or review, so either additional examples I was doing just for them to watch, or some review that I thought they could help, they could use. Sometimes this is just the ones I made. I gave some more review videos, some first year review videos that I already found in the web, so there were quite a lot actually. That's some of them are good. They had to watch, on average, 2.93 videos per flip session, okay? And this corresponded to about 3.38 videos to watch per week, okay? So really, per week, it was not that bad. The thing is, that last summer, we had the Congress here, I don't know if you remember, so we had a lot of one class per week type of situation. And also, keep in mind that this is only about 70% of the lectures. There's another 30% of the lecture where I was doing some more traditional approach, where the students didn't have to watch anything. So on average, they didn't have to watch that many per week. Okay, 3 to 38. Now, the slower video and the faster videos. So if you average them all, so they have about 16 minutes, 45 seconds for the slower videos and 10 minutes, 57 seconds for the faster videos. When I was making them, I was hoping this would be a little lower. It ended up being a little higher, 10 minutes. I wanted this to be closer to 7 minutes, to have something that would be very much faster than this. But it turned out not too bad, and as you'll see, the students actually quite appreciate that. Okay, so this is overall what they had to do before coming to class, in the classroom. Okay? Yeah.
So in a normal teaching traditionally, you would have 3 hours a week, or 3 50-minute sessions.
So it would be 2 1.5, so 2 75 minutes.
Okay.
Right.
And so if you will, the presentation of the information using the slow videos, 3 hours of 3.9, or let's call it 3.
Yeah.
3 of those a week would be around 45, 50 minutes.
Yeah.
So it's kind of the equivalent of less than one of the 2 sessions.
Yeah, you can think of it this way, yeah. And then the rest, because I mean, the other, the rest would be sometimes examples or would be put in the non-flipped classroom type.
Okay.
And so, yes, they didn't have to watch 1 for 1 for a ratio, actually. And I tried not to do that because it's a difficult thing to make them watch this before class. So I didn't want to overwhelm them too much.
Okay.
So through the series of problems, sometimes I would introduce a little bit of theory through the resolution, but really not much. And we had theory-based sessions also 30% of the time. So, and that was enough for me to go through. I didn't cut on anything. So I did not cut on anything, and yes, they only had about 45 minutes.
Okay.
Okay. So, yeah, so this is what they had to do before. Now, once they watched it, what did they have to do when they came to class? So, let me just go back here. Okay. So now during class, okay, so for those of you who are familiar with this method, we use light clickers. And so I introduced it, so this is a bit more on my take on the issue here. There's a typical procedure that we went through for those flip sessions. So for the lectures, or I don't want to call them lectures, the sessions, for which the students have to watch videos before coming. Okay, so typically a multiple choice question would be asked, and then students would take a few minutes to think and work individually concerning this question. Okay, so they would take a few moments and then think about it. And after that, they would click me to give an answer of some kind. And depending on what they would give, then I would either move on to another question and say, okay, this is the right answer, this is why we move on. Or depending on the answer that they give a hint. Or just straight out let them turn to their neighbors and discuss about the problem solution and try to convince your neighbor that they're right, basically. Okay, so they would turn to their neighbors at this point. If the problem, I thought, could require more discussion, or they could help them, then they would talk to each other. And then after having discussions with the neighbors, then they would click again. And then after that, we would repeat, or I would explain the solution, or give another hint, or something like that. So we would work through this flow here. So making them work individually and then in team worked out really well. And I'll talk a bit more about this after. And so we repeated this maybe, I don't know, 10 to 12, 13, 14 problems in class, a 75-minute session. So we had a fair amount of time to do stuff. Okay. And the problem that I would give after. So I'll show. Okay, maybe I'll show the workflow that I created, and then we'll see a bit more what's going on. So this is typically what they would see in class. Okay, so we would be in class, and I made extensive use of this software Prezi here that I've been using for this presentation. And the idea of trying to do this instead of using a more traditional presentation is that I wanted them to have an idea of the big picture of what they're actually doing. So what I did is I categorized the problems by topic, and then by subtopic, and then sometimes by resolution techniques, or to whatever you feel, really. And Prezi is a very nice tool for this because it helps you visually get really quickly an overall idea of what's going on. And as opposed to just having sort of one question after the other where you just see the question. So here's an example. For example, this is one session here where we did talk about curves and motion in space. And there was 2 really big subtopics we had covered. So distance, more specifically arc length, and curvature. Okay? And then we would go on in this problem-solving tree here. For example, if I go on curvature, and then if I click on the first problem, there we go. So here's a question. So they would come to class, they would have watched the videos, and then I would throw this at them. Okay, so which of the following represents the graph of the curvature kappa of the curve y equals x squared, blah, 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 when x is in between -3 and 3. So then they had 4 options and another option which is none of these. And you zoom in very nicely here to see, to focus on every of those solutions individually, so that sometimes the graphs are a little bit harder to see, so you could go around and present all 4 options here. Okay, and then I would give them a bit of time to think about it, and then they would click and give me an answer. Okay, then I would have on the screen a display of all the solutions, either on the screen or not. Okay, you have the choice as an instructor to have it on your clicker base. And then, depending on what they would give me as an answer, then I would make them think about it again with their neighbors to see whether they could find the answer to this question or not. And then after that, I would try to answer it or give some kind of hint. So in each case here, I mean, I try to do slight alterations of the solution to try to catch some typical mistakes, maybe. Okay, it's not always very easy to do that, and it takes a lot of work. But sometimes it works well for some questions, for some others not necessarily as well. But you could try to set traps for your class, basically, and after that, if you catch them, then it's good, because they don't do this mistake, or hopefully not, on the exam. So this is a typical problem here. And then after that, or once we've explained this, then we can move on. Sorry about that, I shouldn't do this all the time. To either a similar type of question here. Okay, and this, what I'm doing right now is exactly what they would see in class. Okay, so they would see that sometimes we would skip questions. And this is not always what's being done, okay? But I found that they actually sort of appreciated the method more by me doing that in their face, more than in the background. So really, and in the end, after that anyways, I gave them all the questions for them to review if they wanted to, but not the answers. Okay, I still wanted them to come to class. So here's another example here of a similar type question. And after that, we would move on to a question, for example, that would look like this, which is the following: does not give the equation of a curve with constant curvature. And here, for example, you have a circle and then another circle, a half circle, and then you have a line, and the other one there is a part of a hyperbola. And so you first have to figure out what these things are, and then eventually which one doesn't have constant curvature, if there's one. And so, typical hint I would give here, if they don't know what's going on, I would try to make them find what each curve would be, and then once they figure out what each curve is, then I would re-ask the question again, and then see what they answer. Okay? So, I prepared quite a truckload of questions like this. Okay, sometimes we would, when there's a lot of formulas, for example, here curvature and acceleration, there are a lot of formulas. They are presented in videos, but I would still remind them in class because they are quite extensive. And then we would do questions such as how to use those formulas, for example. It's not always easy. So here's another question. Which of the following position vector would you plug in this formula to obtain the normal component of the acceleration of the curve y equals 2 minus x squared on the xy plane at the point minus 1, 1? Okay, so really how to use the formula. And so I tried in class a lot like this to work on conceptual questions. Okay, so of course there's a lot of computational questions as well. But try to get them a conceptual idea of what happens. So see here, the question really is, how do you parameterize this curve so that you can use this formula? Okay. And so therefore, this is what I was trying to do. Now, there's a lot of room for making this better at every iteration you actually present this type of method. Okay, and because building questions like this, plus the videos actually take a lot of time, but in the end, you could also do those questions called on the fly. Okay, so if you are in the classroom and then you realize you didn't make another question of this type here, but they're struggling with this, then you can come up with another question on the board and then they solve it. Okay? And eventually, as you do a few iterations, then you will have a lot of questions so that your flow could really depend a lot more than what I'm presenting here on the student's answer. Okay. So this is fairly typical in flipped classroom, but the idea here, or the novelty, is that, or what I had in mind at least, was to try to target for them visually what they're working on and what potentially they would be struggling on. Okay. And so there's a lot of potential to this, I find, which I could probably done a lot better. But what I was thinking too is that you could group some of those problems later on that have similar resolution type under a category, and then you can link this category to a video. So, for example, whenever students have a hard time with some kind of problem or resolution type that they just don't understand, then they could directly go see the video. and then they could get an extra explanation on it. Okay, so there's a lot of potential I find with this. For two reasons, because students can target really quickly what, or at least in theory, what they're struggling with, and for them to get also an overview of what you're actually doing in the class and how it links with each other. Okay, so, and it's not that much more work. I mean, Prezi like this, if you want to get more technical, Prezi like this doesn't necessarily support LaTeX, but you can import everything as an image, and it actually doesn't take much time. And then if you create some nice graph questions like this, once you create yourself a template, it becomes pretty fast. So you can have questions done like this. Really, the bulk of the work, again, is to figure out good questions more than doing them. Okay? And so, yeah. This I find is something that has a lot of potential, but again, because it was the first time I was doing this last summer, I don't think I've used this to its full potential. Okay? And I think this is something that I really want to refine as I keep working on. Okay? So, with those questions, what would the instructor actually see? Okay, so I showed you what the students see. Now, what do I see as an instructor? So if we go back to the very first question that I presented here, so this is what they would see on the screen, and then what I would usually do is I would have my laptop nearby, and then I would just have the text file open. Okay, so for those of you who have done this before, this is a text file here, and then I would put here, as I was building those questions, well, of course, which one's the correct answer, but also a little note on every other potential wrong answer in some sense. So that very quickly, because when you start making a lot of questions like this and the students give you an answer, you have to think fast. Like, which one is which type of mistake? And so what I did is I just opened the text file like this on my laptop, and I would just have a quick idea of why they're wrong. Okay? And this will be very helpful if I know they're all answering D, then I know it's because they're actually thinking of the reverse. So the curvature, they're thinking of it in the opposite way. And so I could think of this way, and then this would be very helpful for me to give them hints. Okay, so this is what I would see, and then of course the iClicker base. Okay, so for those of you who are used to it, you see the numbers here associated with every question, so you don't have to put them on the board or on the projector to see them. So you can see as they're all answering which one is answering which. Of course, I mean sometimes they just answer a random question because they have no idea. A random answer, but I found this was particularly helpful when it was time to give hints to students. And so here's another example here. This is something, setting up of integrals is actually quite difficult. Double integral, triple integrals, figure out the bounds. And so there's a few options here on how to set up the bounds. And again, I would have my text file here, and then I would have roughly what's happening. It's not always very meaningful, but sometimes I found it was actually quite helpful. Okay, and finally, just none of these here, even if it didn't always match up with the question, they were used to it. This is just the answer that doesn't match anything else. And this is actually quite a lifesaver, because when you're making tons of these questions at night, you make mistakes. And then if you don't want to look too crazy in class, then you just put one of these. And then when they all answer none of these, you're like, well, it's none of these, even though your answer, you thought it was B. So this is a good way to get away from looking too crazy in class. Anyway, so this is what I did when I was doing the full classroom. Okay, so it's a lot of work, and it looks even more work by adding this extra pace video, and I'm making all this sort of flow going on. This is something you can sort of incrementally adapt to your classrooms as you teach the same class again a few times. You don't have to do this for every lecture, really. So now for the other 30% here, so what I did, this is a bit more traditional. So keep in mind that one of my macro objectives was to decrease or as much as I could the note-taking in class. So what I did is I just typed my notes from my previous years of lecturing for these. And so they would get a little note booklet that would be partially filled. Okay, I would give room sometimes for a bit of theory that I would put on the board, but minimal, and then I would give room for a lot of examples. I would present the theory, this is I would do in a small lecture, and then I would let them use the additional time, the time that we're not copying down things in a very inefficient way, to actually work on more problems in teams. Okay, so this is how it would look like here. So they would get, I don't know, a 10-page document for this lecture, or I don't know, 8-page. And then we would talk about the theory like this. This is exactly what I gave them, like this. It doesn't take that much work to LaTeX if you're used to it, something you're just copying. Now those little images are something that I've actually had done in the previous year, so I just uploaded them, and then made them a little booklet like this, so they would have notes, and then we would explain multivariable optimization. I just go through to them. It would take me, I don't know, 20 minutes, half an hour sometimes, and then we would do examples. So I would do an example, and then I would put them in team, and then they would do a lot more examples. So there's, I don't know, 8, 7 examples. You could just keep going. I would give them the solution on the website afterwards. For those I created usually more than a little bit, because some of them were really good and they got really ahead, and some of them took a bit more time. And I would just go around in the teams, and those, because of the way we organized the flipped classroom session, they were really used to work with their neighbors or their little groups. So they would just naturally have their hubs already. And then I would just leave them do that, and then they would just work together naturally. So this is very easy to blend in with those flipped classroom sessions as an alternate. Okay. So I'll give them this, and then we will work on that for the other 30%. Okay, I made sure that those 30% of the sessions, they didn't come 2 in a row. Okay, so I always try to space the flipped classroom with one of them, those more traditional one, and then more flipped classroom, because I didn't want them to have too many videos to watch in a short period of time. That was always my fear. Yes?
Which classroom did you teach this in, actually?
It was in ECS, one of those in engineering.
112, or?
Yeah, something like that. So it was,
So it was a tiered classroom,
Yeah.
as opposed to a classroom like this, where it's
Yeah.
easier for small groups to get together.
exactly. So
How did you find it with the students being able, I mean, often a lecture classroom, even if they've got desktops, it's very difficult often people to get into
Right.
smaller groups because
Right.
of the limitations of.
right. Sometimes what I did is I rearranged them a little bit so that I was able to navigate, because they would get very cluttered in some points. But there was enough space for me to walk around, and I'm not. I mean, I'm almost 2-dimensional here, so for me it's not bad to go around. But I didn't find it a problem, the disposition of the classroom. It could be a problem in some classrooms for sure.
If you had an option though, as a professor, would you would a room like this be more adequate if it was larger with a flat space?
Yeah, I think it would be better.
Yeah.
Just because it's easier to move around.
Mhm.
And then this is very nice because you can reorganize the desk to actually have some teamwork face to face, whereas there they were just working with their neighbors, really.
Exactly. Yeah.
But I found even that was already good. So, but yeah, that's a good point. Any more questions? Okay. So, yeah, so this is what happened roughly. Now, well, this is what I did. Now, what happened? So, let me just go back here. Okay, the results. So, first thing I did, well, you gotta see when you do something like this, quite nervous about it, because I mean, you're changing completely what you're doing and you're throwing everything you have at it. So I did a little survey in week 4 to try to make sure that they were still on board with me at that point. And so this is week 4. I think it was this, I don't remember if it was the first or the second lecture that week, but it was week 4. And I gave them a few questions to answer at the beginning of class. Here's one of them. How many videos did you watch before class? Okay, there's 3 to watch. There were 3 to watch. And then I had an overwhelming response of, I watched 3 videos. So I was quite pleased with that. Some of them actually watched all 6 or more. And this is something I found afterwards, what some students would do. They would first watch, or either they would watch the slower one first, and then the faster one to get, again, a better idea, or they would start with the faster one just to get an idea of the material, and then they would move to the slower one and take their notes. So they actually, some of them were using both to as a study tool. But this is really, I mean, what I was hoping to get, and this is what I was getting. So I was very happy because, again, this is dangerous. If you don't get something like this here, then it could go the wrong way very easily. So this was very good. Very happy about that. If you looked at both slower and faster paced video, which ones did you prefer? And we've got, well, a few of them didn't answer because we didn't know those 2 pace. But, I mean, it takes them a bit of time sometimes to realize that. Slow and fast, I mean, fair amount actually liked either. And then about 6 liked both, have access to both. And then depending again, I talk to them, or sometimes in the course evaluation, some of them tell me, well, one day I didn't have much time, so I watched the faster ones. But then the next lecture I had more time, so I watched the slower ones. So some of them actually really like having both. And so this showed me that the fact that I was actually creating these two paces was probably helping them, or to pre-watch, or helping me at least, getting them to watch. So this, I thought, was very good. And it was not that much more work than just doing one slower pace. Some comments. So I asked them concerning videos, what do you like about them? What could be improved about them? This is still before survey. Okay. What did you like about them? Possibility to rewind, pause, rewatch lectures at their own pace. So this is typically what the kind of comments you get in the flipped classroom, I imagine. They really like that because they can go at their own pace. The clear explanations in the videos. So I mean, that's more how the video is done. But two paces available. So this was the third most frequent comment. So 21 students said they really liked the possibility to rewind, pause, rewatch, but 5 of them said the two paces is actually helpful. And then what could be improved? Well, give more examples, make them shorter, use more colors. So eventually I adapted the videos a little bit because that was only week 4, so I changed a little bit how I was doing. I did use more colors. What could be improved about them? And then for the clicker sessions, what did you like about it? Well, you saw a lot more examples in regular math class. This is also very typical of this method because you do a lot of examples. The instant feedback and more opportunity to apply learning and think about the material. And what do you think could be improved? Well, give access to the questions online. So that at that point I wasn't doing that. So then I decided to just give them all my questions afterwards, all the clicker questions, even the one we didn't work through. And some of them would very diligently do them all after class. I wouldn't give them the solutions. So they have to come to class to get the solutions. And yeah, give more explanations, give more or less time to answer questions, but I mean, this is something you navigate through questions. One thing I didn't mention though, when I was doing those flipped classroom sessions, I was not, at any given point, I was not giving any summary of the videos in class. Okay, I really wanted them to watch the videos. And I was thinking that if I start making a 5-minute summary at the beginning of lecture about what they should have watched, then they probably wouldn't have watched it and just waited for my summary and then tried to live with that. So at no point did I give a summary of my videos. I asked them if they had any questions about the videos when I started, but I did not give a summary about the videos. And I think this was also very helpful to get them to actually watch it. Okay, so this was week 4. Now, the end. So course evaluation. So this is at the end, summer 2013. These were now the numbers I got in terms of what they actually appreciated. I'll get to more details in a minute. But I wanted to show you this. I mean, I was very happy when I found that this was a 0.5 increase in their engagement. So they did feel like they were more engaging with this method. But also, everything else improved. It wasn't just that. They just liked everything. And so I got a really high rate for the effectiveness in the course and the learning experience. So they really thought it was a good learning experience overall. So I was quite pleased with that because these were the highest course evaluations I've ever had at this point. And so now I tried to look at their comments and then try to understand why they bought it so much, right? Because this is what we want to achieve when we're doing the flipped classroom. You want them to buy in, and then once they start buying in, then they realize the benefits. Okay. So more details about the course evaluations here. So one thing I was afraid is that they would feel like it's way too much work, because they have to be really disciplined, they have to watch those videos beforehand, and they still have to do the assignments, and they still have to do the suggested exercises. And so typically this is how much work, I mean, if you take an ideal student, the ideal student probably wouldn't think it's more work, because the other student would review their lectures anyways. But the average student wouldn't do that. But I was very surprised to see that the question here, the workload of this course was, well, extremely heavy, somewhat heavy, average, or somewhat light. So this is 2013, and if you look at 2012, it's about exactly the same. I mean, there's different number of students enrolled, but it's pretty bang on the same distribution, or very close to it. And so they didn't really feel like it was more work to do that than the previous time I was lecturing, okay? Which to me was quite significant. And also, the approximate number of hours per week I spent studying for this course outside of class almost the same thing. So see here I had about 19 hours, 19 students between 2 and 5 hours, and 18 there. And then some kind of normal distribution after that, or close to it. Okay, so this I was quite pleased with as well. Now, this is what they have to say about the main strength of this course. The videos. Overwhelmingly happy with the videos. And so I put here in brackets, try to categorize the students' comments is always a bit difficult, but I put all the comments they gave me, that 2 or more people gave me here. Okay? And they like the videos, they like the clear explanation, the flipped classroom, lots of examples. The variety of help tools, and I thought this was very nice because there's really quite a selection of things here to try to appeal to people who actually like lectures, people who like the slower pace, faster pace. So all this variety of help tools, I suspect actually made a big difference in actually how they enjoyed this class. Because really, some students will prefer one aspect, some other students will prefer another aspect. And yeah, so this was in some sense trying to please all of them to some extent. So, yeah, good, the use of technology, so this is all things that only happen twice, but the videos, they were really liking videos, basically. What could be improved? So add a review of videos at the beginning of class, which is purposely what I was trying not to do, since a lot of people didn't want that, but I did tell them explicitly, actually, why I wasn't doing that, and they still wanted a review, but I didn't do it. A lot of them said it requires a lot of discipline, actually, for them to watch videos ahead of class, which is a big drawback of this method, really. But for them, it's not that bad. Method takes time to get used to. That is true. A lot of them are very used to the traditional lecture-based methods, so for them to do anything different, they take a bit of time to adjust. And initially, I would say, I try to do really big sales pitch at the beginning of class. Why are we doing this? Why does it make sense to try to do something like that? And I think because I did that, I think people bought in faster. And this is crucial because it starts going really fast after that in the lecture. Okay, and some people wanted more no-booklets, and always people find it too hard. So this is a hard class. So it's typical of what you get in the course evaluations. The participation with respect to clickers. So I didn't really talk about the grading scheme here, but this course had 2 midterms. I put them 20% each, and the final was 50%. And then they had 8% for assignments, 2% each, and they had 2% participation. Okay, and I was trying to put the 2% participation to link it with the clickers. So what happens is every time they would come to a clicker session, as long as they clicked at least once, then they would get the participation mark, and then the total participation marks would add up to 2% at the end, minus 1 lecture or 2 that I just gave them to go on vacation or whatever they do in the summer, so if they're sick or something. So this is what you see here is the plot of the final grade in percentage they actually got in the exam as a function of the participation mark. Okay, so of course these are all the people that never missed a flipped session. I didn't take attendance on the non-flipped session. Okay, so these are just for the flipped session. And then after that you have the distribution, and they get a nice trend line that goes up like this. Of course, this is just you have a lot of data here and a bit over there, but this was a bit interesting. And then this is actually what happened in terms of the grade of the students. So 2013, so last summer, 52 students wrote the final, as opposed to 60 the year before and 45 in 2011. Okay, so enrollment, I was afraid a lot of people would just drop the class when they would see what I was up to, but that didn't really happen, so that was okay. So in 2013, so I gave a grading scheme that had 1 less assignment and 2% participation mark. And I also reweighted the things a little bit after I started thinking about my teaching a lot for the final to be 50%. Because before in 2012 and 11, the final was 60%. And then the midterms were 15% each. And the 60% final I always thought was atrocious because it's in August at that point. So, I mean, to put so much weight, especially at the end of the summer, they just want to get tired, they want to go on vacation and do something before the term starts again. And 60% was pretty crazy. But anyway, so the average was 67.3 of all the students who wrote the final, as opposed to 66.6 if I had used the previous year's grading scheme. Okay, and that is assuming that one of their assignments they had 100% on it, really, because one of them was participation mark. 2012, I had 60 students. the average was much, much lower. But that year, there's a lot of students who just showed up at the final and got less than 10%. So, I mean, it really varied. I had a really good year this year. The students were really good. And actually, I think 7 of them ended up being math majors that year. But this year was quite different. So it's very hard to draw any parallel. Even though I taught the same class 3 times, every year the student body was quite different. And so it's very hard for me to draw any conclusions on this. If I had maybe taught the same class the same summer, just 2 different sections, then maybe I could have been having better parallels between the 2. But now, every year I found it was quite different. I mean, it did really well, much better than the previous summer, but the summer before it did better. So, I mean, it's hard to say whether this is actually making a difference or not. But in terms of how much they actually felt engaged to it, then yes, it made a difference. And then finally, so just to wrap up, so some thoughts and recommendations. Verity is good. This is, I think, from talking to them, from having read the course evaluations, I did a little bit of a lot of things here. I mean, lecturing, team problem solving, the clickers, with the videos. So they really had a lot of things going on in that class. And I think, to some extent, they liked that, whether they realized it or not. So, Verity is good. I think this is one of the key aspects that made this course so successful. Second take-home message, really, when building videos, the additional effort of making a second page seems to be worth it for the amount of time I had to put in. Okay? So if this is typical, or this is more associated to the type of videos I had in mind. Okay, so of course, I'm just doing just like a lecture for my slower paced video, and then I create a faster paced video that is faster. If you're not doing that, then it's a bit different. But if you are thinking of doing this, I just saved the text and I just read over it, and that made, I think, a big difference. After that, the idea of grouping in class clickers problem by subject or else could be better exploited. So what I was doing with the Prezi, this sort of flow of questions that you could sort of categorize a bunch of problems according to what you want and link that to the videos so they can have additional explanations. They could take notes in class of that. I think this could be better exploited. So this was my first take on doing it. And this is something I plan on actually trying to exploit a lot more. This visual aspect of this tool that I'm using in Prezi in the future. And this approach takes a lot of effort. Of course, you guys probably didn't see it much last summer. But it can be slowly integrated to an existing course at every iteration. So this is sort of what I realized as I was doing it. Because in the end, I was doing 30% regular lectures and 70% for the classroom. But at some point, you can, if you already taught a class using a lecture, then you could try to integrate maybe 30% of the classroom in it. And then if you think it's worth it, then keep improving every year, 10 to 40, 50% eventually. And then that way it's much more manageable in terms of the workload you have to do. And then, of course you have to ask your students to buy the clickers, which is a bit of an investment, especially if you're only going to use it a few times during the term. But there are alternatives. I've heard of some other math instructors who use a little piece of paper to just raise whatever piece of paper you have, and then already that I think the students appreciate. So, so these are just a little bit, a few thoughts and recommendations. Thanks for coming. Any questions?
I have 2 questions.
Yes.
What, do you prefer it? If so, it's 3. If so, what do you prefer about it? And do you think it releases time? Is it more efficient in the long term for you?
So once you have your material built, I found that it was actually less work to go through one of those iClicker sessions. Every time I taught this class, lecture style, before I give them every note, so say the summer 2012, when I was just lecturing and writing things on the board, you're drained as an instructor when you get out of there, because you do the whole show, right? Whereas there, the difference is it takes a lot of work to actually build the material, but once you have it, I was going through my class, and after my class I was like, wow, I could just keep going, because they're doing a lot more. They're engaging, and before it was just me putting on a show. So I found it was way easier to actually go through a session like this than to go through a regular lecture style session like I'm doing right now, really. Because of that reason, because they're doing a lot more work with themselves. And I found very often, in a very large classroom, it's difficult for a prof to go around and help everyone, but they were helping each other a lot. And so the good students will have the students had a bit more issues, and then I would go around, make sure everything was okay, but a lot of the time, some students were helping each other, and then that was good. So it made a big difference.
I asked Jason the same question on Tuesday. If you were going to teach this course now this summer, would you use this method or go back
Oh, yeah.
to you'd use this method?
Hands down,
for sure.
yeah, for sure. Especially I have it all.
Yeah.
So, and this is something that's nice too. I mean, within the department, I mean, Jason taught an equivalence for the classroom, and then just shared this question with Rod after. And so, like, I don't see why. I've already shared these questions with one of the instructors doing Map 200 right now. I think it's someone from engineering this term. And so, really, I mean, the work is really to sort of figure out good questions. Once you get used to, once you have your template, and once you have your template for the video, and you have the things ready, that becomes fast. It's just building it that becomes difficult. So then, I mean, if I were a young instructor again, what I would do is I could just prepare, half the term for a lecture, or maybe a bit less, and then do the rest with this kind of method. So, the 70-30 doesn't have to be 70-30, it could be 50-50, it could be 40-60. And really, I think just having this little extra diversity, students really appreciate. So,
I definitely would say as a student, just the fact that I could review something, be able to pause it, watch it again.
right.
You don't get that option when you're sitting in a lecture.
No, when do you pause the instructor and then you rewind and then back forward?
You're making some sort of vague note that you're going to have to ask somebody else if they got it.
Right.
And if it's a difficult theory or something, it could be the people all around you have no concept of it because it just happens so quickly, right?
Right, exactly. And so, as an instructor, you get a much better feel of what your classes actually do, or how your class is doing when you do this, because you get direct feedback. So it's feedback for both the students and the instructor, for sure.
A few years ago, we did a lecture capture series, and it was for a course here on campus for Greek and Roman studies. And we would capture the entire class and then post it online, so students could more or less use it as a review tool, not so much as a flipped classroom. And all the videos we posted on the UVic secured server site, so people had to log on to it. They actually had only UVic students that could see it and know where it was. And the nice thing about that was at the end of the class, at the end of the semester, we were able to graph when students were viewing the videos and where they were. And it was very interesting that the highest rate was between midnight and 4 o'clock in the morning when they were reviewing their videos. And there'd be these big spikes right before midterm and right before the finals when they would be reviewing these classes.
And you see, to some extent, I had something similar here, because my channel, YouTube channel, was open to everyone. But my channel wasn't really popular because I just started it. And so you have this very good tool, analytics, because Google bought YouTube now. I think so. I have this really good analytics tool, and then you could see before every lecture a little spike